What is a function in mathematics? So it's defined as it's a relation between two variables x and y such that for each x there is exactly one y. So we could also say that each x determines a single value of y. X is called independent variable and y is called dependent variable. X is also called the input and y is called the output. Let's try to understand this concept through an example. Let's say we have a variable x. This is defining some chocolate bars, and the variable y, it is defining as the price of these chocolate bars. Now look at this picture. Here we have x's, here we have y's. Let's say there is this chocolate bar. Its name is A and it has two prices. One is $1 and another is $1.02. Now let's check this out, that if this relation defines the function between these two variables x and y. So here 1x, which is A is associated, or it is determining two outputs, which is 1 and 1.02. So would we call this a relation, this relation a function? No, this is not a function. And why it is not a function? Because here for 1x we have two values, which violates the definition of the function. Let's look at another example. Let's say we have two chocolate bars now. And the price is $1. This is x, this is y. Shall we call this relation between two variables x and y as the function? Let's check out the definition of function first. What does the definition of the function says? It's a relation between two variables x and y such that for each x there is exactly one y. So here in this example too, A has one y value, which is 1, and B has another one y value, which is 1. So they don't have to be the different, as long as the definition holds that each x determines single y value. So in this case the definition of the function holds. So we say that this picture represents this picture, or the relation between the variables x and y, as the function. Or you could just think of it as two chocolate bars, A and B, having the same price as $1. Let's try it through example 3. Again, we have two variables x and y defining a relation, and we have to check that if that relation represents a function. This time we have, let's say, 3 chocolate bars. The chocolate bar A has the price $1. Chocolate bar B has the price, let's say, $1.1, and chocolate C has the price $0.9. So shall we call this relation a function? So each x here, in this case A, let's say, is associated with 1, B is associated with 1.1, and C is associated with 0.9. So each x determines one y value, or one output. So we say that yes, this relation also defines a function. One more example. So in this case there is this chocolate bar. or we can also think of A as some person, and Y is the age of that person. Let's say X are the people and Y are the ages of these people. So let's say it's 15, 16 and 17. So in this example 4, does the definition of a function hold or not? So it's what is happening here. A person A has age 15, 16, 17, which is not possible. One person is associated with only one age number, so the definition of the function does not hold. So this example 4, in this example 4, the relation is not a function. And let's try one more example. Since we are saying that a function is a relation between two variables, so this function could be represented algebraically in this form: y is equal to f of x. So since x is taken as the independent variable and y is taken as the dependent variable, so what does this say? That whenever you plug one value of x, if this relation is y equal to f of x, if this relation is defining a function, so every time you plug in one x value, you should be getting only one output, which is the y value, right? So this relation will define a function. So let's say we have this algebraic equation y equal to x square involving two variables x and y, and we want to check that if this relation represents a function or not. So since we are calling x as the independent variable and y as the dependent variable, so we take x values of our choice, and every time we plug in x value, we will be getting the y values. Let's say if I take x equal to 1, this gives me y as 1. If I take x equal to, let's say, minus 1, I get y as 1. Let me take one more x, which is 2. So I'm just taking randomly x values, gives me y as 4. Let's represent these numbers in the form of a picture. So here we have x values. Here we have y values. So the x values that we had taken for this example were minus 1, 1 and 2. So what answers did we get for minus 1, 1 and 2? For minus 1 we got for y as 1. For 1 we got again 1. And for 2 we got 4. So let's check that if this picture represents the definition of the function or not. So for each x which is minus 1, 1 and 2, are we getting a single y value? So for minus 1 we got 1, for 1 we got 1, and for 2 we got 4. So we, for each x value, yes, we are getting a single y value. Again, this here there might be a confusion that for minus 1 and 1 we are getting a the same y. So that's the definition of the function does not concern with this. So as long as for each x you are getting a single y, so it will represent that relation will represent a function. So we will say that yes, the picture represents it as a function. So we'll say that y equal to x square is a this relation represents a function. We can try another example. Let's say we have a relation described to an algebraic equation, which is y is equal to plus minus square root x. And we want to check that if this relation y equal to plus minus square root x is this function or not. So again, we will take, let's take one x value. because we are calling x as independent variable and y as dependent variable. So when we take x as, let's say, 1, we get y as, so square root 1 is 1, so plus minus 1. Let's represent this in the form of the picture. So we took 1 as x and it gave us two answers, 1 and minus 1. Now let's see. Let's check the definition of the function. So for each x we should be getting single y. So here for 1 we are getting two y's, 1 and minus 1. So the definition of the function is violated here. We'll say that this relation y is equal to plus minus square root x is not a function. Fn is for function. So through these examples we have understood that a function is a relation between two variables x and y such that for each x there should exactly be one y.